Good morning, good afternoon, and good evening, EL 115 students. I'd like to take this time to be able to do a quick walkthrough of the first three questions that are due on Monday. Kind of an idea of how to look at these questions and how to determine what answers you're looking for. And you'll have to excuse me, I'm trying a new piece of technology out. I've got one of these fancy uh, pens that mark and do all kinds of stuff here. So if you get out your week one reading and review questions, there's three of these questions in here, okay? And the first question asks, what is the maximum continuous load that may be connected to a 20 amp, 120 volt circuit? Okay, so now we have to break the question down, and we do this by looking at we're going to pick out the key words. So I'm looking for maximum continuous load. I want to be able to know I've got 20 amps. And the question here is, do I need this information? For this particular question, you do not. Okay, so if you've gotten your reading taken care of, and you were in book three, module 1, and you're reading through, make sure when you're reading these, you're reading the informative notes. So do you remember the reciprocal, where you can take 1 over a number and be able to flip it in basic math? Basically, what we're looking at is this. The reciprocal, as it were, is 100 of 125% is 1.25. Okay. In our reading, it says there, it talks about continuous duty and non-continuous duty loads, and some of it 100%, all of the continuous duty loads at 125%, and which is more than 3 hours if you're looking right here above this. Just supported branch circuit rating shall be not less than the non-continuous load plus 125% of the continuous load. So what does that mean? So it means shall not be less than the non-continuous duty load, which is the stuff that doesn't happen all the time. So you want 100% of that. And then you want to go with 125% of the continuous load. Now we're talking about loads. Loads run any more than 3 hours at a time. But anywhere you're looking in here, you're going to find 125%. It's going to say 125%. It likes saying 125%. There's lots of different places in here where it talks about 125%. Well, our question asks about the maximum continuous duty load that we can put on something. Well, and that's where this little reciprocal, this little note here comes in. The reciprocal of 125%, which is 1.2, is 1 over 1.25, which is equivalent to 80% of the rating of the overcurrent protection device. I.e., you will get the same result when you divide by 125 as when you multiply by 0.8. The reciprocal can be used to calculate the maximum load that may be connected based on the circuit rating. So whenever you have a breaker or a fuse and they give you that and they want to know how much you can put on it, you basically need to put in your mind, I can only do 80%. So with that being said, let's work the calculation, shall we? So we have a maximum continuous duty load. Okay. We don't know what that is. We're saying how much can I put on it on a 20 amp, 120 volt circuit. So the question here is really, do I need the 120 to do this? Well, no. No, literally all I need to do, change the pen here, is take this to where I do this right here. What is 80% of 20? So like we were talking about before, we can use this math right here. I have 20 times 0.8, which is 80%. Tells me I can put 16. That means I can put 16 amps on this particular circuit. So what does that mean to us? Well, in our question, Question asks, what's the maximum continuous speed load that can be connected to a 20 amp, 120 volt fuse? Well, look, I have 10, 16, 20, and 125. Well, right there is our answer. That's the guy we're looking for. So if you answered B on this, you did real good. Okay? So the answer to this one would have been bravo. Okay, so now question number 2. It's a voltage drop question. Well, we need to come up here and look at this formula. As a matter of fact, I've put formulas here for everyone to understand. I've got a cheat sheet here. This voltage drop, okay, this is the formula to be able to factor voltage drop. So voltage drop, a permissible voltage drop, okay, for a branch circuit is 3%. The permissible voltage drop for a branch circuit and a feeder is a total of 5%. And electricians have gotten this wrong a lot over the years because we think it's 325%, but when you read it closely, any branch circuit, okay, is going to require only a 3% voltage drop. Okay, so let's break down what this says. So we have a VD, right? We have a voltage drop, okay, and it's equal to 2. Well, that's a number, and then it's going to be times K, which is the K factor is 12.9. That means that is the some of the properties of copper whenever you're talking about doing these type of calculations. Then you have amperages, I, which we see it up here is right here. Current can be in amps or milliamps. And then we have L. Well, depending on which book you're looking at, okay, that L could be a D. So basically, I want you to understand that length and distance are the same. We're talking about the amount of footages. Okay. So let's go through here and do this calculation pretty quick. Now, with this particular one, anytime you're talking about, oh, there's one other thing I want to point out to you. This guy right here. You see that? Circular Mills. Circular Mills has to do with the table in the back of the book. So, chapter 9, table 8. So that's where you want to go. Now you want to come over here to the circular mills here in just a little bit, and we're going to be looking up some stuff off of this table. So let's work this calculation, shall we? This is one of the harder ones to be able to do because there's still a lot of points to it. So I have 2 times my K factor. So I have 2, 12.9. Point's not very good. Times what? What's my amperages? What's 28? Times my length, which is what, 160. Okay. Well, I need to be able to divide that by a number 8. Well, that number 8 doesn't tell me what these circular mills are on it. So I come down here and I look for a number 8. Well, my number 8 wire, its circular mills are 16,510. So that's just the number you're looking at. That's the number for the equation, 16,510. So let's go back over here, and this is going to be divided by now remember, we're looking for a voltage drop. And it's going to be 2, which is your 2 up here, 2 right here, times your K factor, which is copper, and this is copper wire because it's telling us it's copper wire, 12.9, well, we've got that in there. Now we multiply 28. Well, 28 is our current or our load. And then we have our length, which is based right here. So there's the top part of the calculation. Secondary, we went back and found the number 8 off of the chapter 9, table 8, conductor properties, and found out that it has 1600 510. So I'm going to minimize this where I can actually see the work, where we can work on this together. Let's put this guy over here. So we have 2 times 12.9 times 28 times 160. And that equals a great big number. Well, we got a big number right here to go into it. So let's see what that does. So we're going to divide that number by 16,510. It's going to equal, guess what? With that size of wire, our voltage drop on this particular situation is 7. So what does 7 mean? That means I'm going to lose 7% of my voltage. So if I send out 208, when I get out there with the distance, it's going to be 7% less than 208. So the answer on this one should be 7%. Let's see if my math worked with 6.97. That's one real close. So I have our math went a little bit long. Let's go back to the calculator to see. 6.97 and 7 are very close to each other. I'm going to call that as a good answer right there. Whoop, right there. We'll take that one away. Our answer from the previous one was Bravo here. And there we go. So now we have determined using this formula that you're going to get a 7% voltage drop. Well, what does that mean? Well, if I'm sending 208 volts out, let me get down here. We'll bring this up here so we can play with it. I like playing with the calculator. So if I'm sending 208 volts out, minus 7%. So I'm going to lose 14 volts, 14.56 volts. So let's do that math to see what I'm going to get out there. So it's 208 minus 14. I'm going to get 194 volts. Now that gets us to where we're outside of our code because this is a branch circuit and it should be at 3% for the voltage drop. All right, team, so we're down to the very last one here. And what is this one? This is question number 3, right? Well, that's not what I want to do. So question number 3 says, what the ampacity of 120 volts, single phase, is rated at 800 VA. The ampacity of 120 volts, single phase load rated at 180 VA, or 80 VA is. So how do I answer this question? Well, right off the bat, it says ampacity. So that means I'm going to find something on our color or charts or color wheels, your calculation wheels or your code wheels, which if you guys are smart, you're using them because I've already posted them to you. They're in your announcements. I want you to have those and keep them handy because you'll need them. I pulled a couple in here. So, ampacity. Well, that means ampacity, that means I. So I'm looking for I is equal to of A. So that means equal to. So I'm going to be using one of these two calculations, minimum. Okay. I've got 120 volts. So I've got E. And I have VA. So VA is watts or power. So that tells me I can use this calculation right here. Okay. So that means I'm going to do I equals P divided by E. All right, Scott, what does that mean? So let's come back over here and let's fill in the numbers. So I equals our P, well, that was in VA, that's power, so it's 800 divided by 120. So let's clear this out. 800 divided by 120 equals 6.666. I don't even like that number, but it's 6.67 is your answer. Everybody see that? That's going to be your amperages. In the end, the ampacity of 120 volts single phase rate load is 6.67 amps. So let's go back over here. I got myself tied up because I was trouble drawing. This should be our answer right here. And knowing that I have the grade book, right there is the answer. So I've given you all three answers to the first section review. B, D, D. I'm hoping that you have found these on your own and have read the material, because in that material is important information that you need to be able to follow and be able to have. This is something you need to remember. Okay? So guys, it's 17 minutes in. I appreciate your time. My phone is always on. My email is always up. I'm always answering it. If you have any questions, let me know. These are going to move fast. We're going to get some serious calculations going on as far as getting used to this Ohm's law and loading of circuits and doing percentages. So be prepared. Do your reading. It is very important that you do it. Get it done. Thank you all. Have a great day.